Good evening, everyone. Good evening. Let me decrease the music a little bit. Camera is on its place. Wonderful. So, here we are. I don't want the music to disturb us. Fantastic. Good evening, everyone. Here we are preparing for the exam tomorrow, but it doesn't mean that this is not relevant for those who are not doing the exam. Today we're going to talk about few complicated topics, but it's going to be worth it if we get the concepts very well. Good evening to David, to CXX Wiki, to Inquisitive User 11. What's up, Mrs. Romero? All good? Just saying hi to the people in here. Just started. Just started. Just started. She doesn't want to come to say hi. She's a bit shy at the moment.
I'm not shy. Where are we?
The camera is there.
Hello.
Alright, no more hesitation. Let's start now, okay? Alright. Let's set the visualizer. More people joining. Wonderful. Wonderful, wonderful, wonderful. I don't want to take more of your time. Let's go to learning. This camera. Wait, what is my camera? Should be working. Give me a second. Should be working well. Hello, Cara. How are you doing? Enjoying your summer holidays? I thought you would be in Thor Park at this point. Just give me a second to check why this visualizer camera is not working. It should be working. Okay. Alright, it is working. So alright, still. So why this is this? Alright, technical issues. Let me see if I can. So you are in transition. That's interesting. Still is black. Why this is not working? Alright. Interesting. Okay, so one of the cameras is not working. Let me see if I can change the USB. Perhaps it's connected to... You know, people who are very good at computing. I really don't understand how they are that good at computing. I think it's horrible. I'm happy that you are coming to school. You are always more than welcome. Still, I need to make this work because today I'm planning to write a lot. Okay. All right, so we will improvise them. Okay, never mind. Let's continue with our lesson without the camera. I will just share the PowerPoint. Okay, we have 9 people already in here, so let's not waste time. So the topic I chose for today is, for you, it will be P6, okay? And it's a topic that is about density, is about internal energy. Hello, is the one that is about a specific heat capacity, a specific latent heat, and internal energy. Okay, it's generally speaking a topic that students, they don't really like it because it has concepts that they are like very long. As soon as you can see a specific heat capacity, you are like panicking, all right, because it has a very long name, or a specific latent heat, you start panicking. But once you get the formulas, things get a bit easier, all right? I will not talk much about density because it's something I did in a previous video, and it's a topic that I think is quite easy. Still, if there is anyone who would like me to talk about density, I'm happy to talk it briefly, perhaps later, all right? But the first one I will talk about is about states of matter. Some of the things I will mention, they are pretty easy, pretty straightforward. For example, I imagine that if I say in the chat, I will not stop to make a poll now, but if I say to anyone in the chat to write What is the change of state from solid to liquid, liquid to gas, gas to liquid, liquid to solid? I'm pretty sure everyone will be able to say that, right? Wouldn't you be able to say that? For example, if I say solid to liquid, how do we call the change of state from solid to liquid? Nobody's writing in the chat. I'm scared now. You should be able to know it. Solid to liquid, melting, very good. Okay, and what about, this one is a bit more difficult. What about gas to liquid? Gas to liquid. Gas to liquid, condensing. Okay. All right. So as I mentioned, some of the things that I will mention right now, they are pretty easy. This is something you already know. Let me see if I can, like, presentation, like here. Fantastic. Ooh, I'm covering a little bit. Let me see if I can move my camera. All right. Here is fine. Okay. Okay. Yes, please, someone ban that person. Okay. All right. Let's start with a few things, okay? The first one is that when we talk about the states of matter, we are talking about physics. We are not talking about chemistry. And it's very common that there is a question like they say, why the states of matter? Why changing the states of matter is a physical change and not a chemical change? And the reason is very simple. Chemical changes, they involve new substances, okay? When you have, for example, I don't know, methane, and it combusts with oxygen to make carbon dioxide and water, where you're combining the new elements to make something that is new or is different from the original thing. Meanwhile, and I say all the time, AQA. No, AQA. AQA for sure. Meanwhile, when we have, let's say, 1 kilogram of ice, we melt it, we get 1 kilogram of water. And when we have 1 kilogram of water and we boil it, what we obtain is 1 kilogram of steam. But if we do the chemical analysis of ice, is H2O. Chemical analysis of water liquid is H2O. And then when we have the chemical composition of steam, it's also H2O. So the substance itself, it is not changing. It's just H2O all the time. Also, something I just mentioned. If we have 1 kilogram of ice and we melt it, what we have is 1 kilogram of water. The mass is not changing at all, okay? Yes, let's focus into chemistry. So, changes of state, they are physical changes because we are not making anything new. We are not changing the chemical composition of the substances, and the mass is not changing during the whole process. And also, important, the process is reversible. What is the meaning of the word reversible? Let me write it down, because remember, when you're doing an exam, you need to write properly, okay? Proper English, reversible. I know that it sounds fun, that is me saying that you need to speak proper English, but it is true. You need to use proper English at all time. Reversible. What is the meaning of reversible? What is something that is reversible? Any physical change. We're talking about, in this particular case, we're talking about changes of state. But what is the meaning of reversible? In general, what is the meaning of something that is reversible? Anyone in the chat? Feel free to answer. Okay, yes, it's something that can be unchanged, all right? Exactly. So something that we can do is, we can go to Tesco right now, get 1 kilogram of ice, melt it, freeze it again, and we will have again 1 kilogram of ice. It's reversible, and we can make the changes as many times as we want, because we are not changing what is ice made of. Exactly. So a few things that tell us that changes of state is a physical change is that changes of states are reversible. We are not making anything new. Mass is not changing at any time, okay? Any of those answers will give you the mark to the question, why do we know that changes of state are physical changes and not chemical changes. By the way, I talk about changes of state, assuming that everyone in here knows what we are talking about. Remember that you need to know four states of matter. But for this exam is 3, okay? Which is solid, liquid, and gas. And what they can ask you, and I move my camera in here so you can take notes if you want to, is you need to be able to describe how particles are arranged in solid, liquid, and gases. For example, particles in solid, the only motion that they can do is to vibrate. That is the key word. In solid, particles vibrate. And they have fixed volume and they have fixed shape. If I want to change the shape of this one, I can break it, but that's the only way I can change the shape of a solid, okay? That's the only way. Then we have particles in liquid, or liquids, let's say. We say that the particles in liquid, they can flow. They can flow over each other. You can melt it, yeah, but that wouldn't be a solid anymore. That would be a liquid, all right? We say that particles in liquids, they can flow over each other. That's why we say that the shape is not fixed. If you get a glass of water, the water has the shape of the glass. If you get a bottle of water, you will have the shape of the bottle. If you have a swimming pool, the water will have the shape of the swimming pool. It doesn't have a fixed shape, but it has a fixed volume. We cannot compress liquids, okay? And then the last one is gas. In gas, particles, they move freely and they are way separated from each other. That's why we cannot see gases. We are unable to see gases. It's because the particles are way separated from each other. That's why for our eyes, they are invisible, okay? We cannot see gas particles. That's the reason, all right? You cannot compress water in a bottle of water, but you can compress air. If you get a balloon, you inflate it, and you have the air inside the balloon, you can compress that balloon. As a matter of fact, if you get that balloon and you put that into the freezer, the balloon is going to shrink. And we're going to talk about later why, okay? But you need to be able to describe how particles are arranged in solid, liquids, and gas. Normally, I think I have it, they will ask you perhaps, especially those who are doing foundation, they will ask you to draw it. It should be something like this. This is how they ask you to draw it, okay? So you have the solids that they are like in fixed positions and it looks regular shape and you see lots of intermolecular forces. Then in gases, the particles, they are like flowing around, and then in gases, they just move freely, okay? They could ask you to draw this sort of diagram. Now, just one thing before we move forward. I understand that you know all the changes of state. There is only one that perhaps is a bit new for you or you're not very familiar with, which is sublimation. Sublimation written like this. What is sublimation? Sublimation is the change of state of a solid into a gas without stopping into liquid state. It just goes directly from solid to gas. That's all. All right? This is not very often, but where are we going to see this? Well, I don't know if you are into going to concerts, but in concerts, they use some sort of fake smoke, and they use what we call solid carbon dioxide. Solid carbon dioxide. And there are some little pellets that when you throw them to the floor, they are solid. As soon as you throw them to the floor, they turn into gas. Okay? And that what is happening is sublimation directly. It goes from solid to gas. But apart from that, I'm pretty sure you know all the different changes of state. Okay? Alright. Something I want to talk to you about is... Yeah. Something I want to talk to you about is the energy that the particles have. Well, the different energies that the particle have, okay? Or also I want to talk to you about kinetic theory model. Alright. First of all, kinetic theory, a model, is a way that we have to explain how particles look like and how substances behave. But we have no clue of actually how particles look like. That's why it's called theory, or that's why it's called a model. Still, it helps us to explain how the things around us, they look like the way they look. Okay? So for example, kinetic theory model says that things are solid, again like this camera, that is not working today. This is stupid camera. This is solid because the particles that made up the camera, they have very little kinetic energy. Remember that kinetic energy, what is kinetic energy about? Kinetic energy is about movement. So kinetic theory model says, alright, so anything that is solid, it is solid because it has a very low kinetic energy. Then things are liquid because they have more kinetic energy, and things that they are gas, they look like the way they look because they have very high kinetic energy. So it's basically explaining how things look like based on their kinetic energy. However, sorry, this model has a few limitations. For example, this model considers that all the particles, they look exactly the same. And it's basically thinking that all the particles, they look like ping pong balls, that they are just moving randomly. We know that this is not exactly the case. And also this model thinks that the only interaction between particles is kinetic energy. But we know, especially those who did chemistry today, that between the particles, we also have chemical bonding, for example, or intermolecular forces. So this is just a limited model. It has its own limitations. Still, because it's not a very common question in the exam, I will not stop in here very much, okay? However, what is very common question in the exam is changes of state graphs, which is what I'm going to show you in 1 second. By the way, if I'm talking very quick, or if I'm jumping from one topic to another one, feel free to tell me to go slowly or to stop. Because I don't know, obviously I'm on the other side of the screen, so I know this topic already. But if you would like me to explain in more detail, just let me know, okay? So I will change the presentation. Now I want to show you this graph. Boom. This graph, okay? The one that looks like stairs. And they can ask you, why does it look like this? All right. In order to understand why this graph looks like this, before you need to mention, or you need to refer to something that is called internal energy. Okay? And it's one of the subtitles of today's video, internal energy. Internal energy is the combination of two energies. I repeat, for those who are taking notes. Internal energy is the combination of two energies. Kinetic energy of the particles and potential energy of the particles. What is the meaning of potential energy? Is the energy due to the bonding. Okay? Is the energy due to the bonding. So internal energy is the combination of the energy that comes because of the movement of the particles and the energy that comes because of the bonding of the particles. Now that that is clear. Why the graph looks like this? So as you can see, in the x-axis, in the y-axis, which is the one that is like vertical, sorry, I don't know, I had like a brain freezing for 1 second. The one that is vertical, which is the y-axis, is temperature, and the one that is horizontal is time. You can ignore this one for now. We're going to focus in the vertical one. You see that for a time, temperature increases, then it stops, goes flat, and then temperature increases again. Why this is happening? And this is something you can all, some of the equations will be, some of the equations they will be not. So following what I was saying, you can test in your home if you want to, but you need a thermometer. So when you heat up something, when you increase the temperature of something, what we are changing is how fast the particle moves. And I want you to, if you have one idea today after this streaming, this is very important. Temperature tell us about how fast the particle moves. Only. Temperature is all about the movement of particles. Only. So whenever you see something that increases the temperature, it's because the particles, they move faster. And whenever you see that the temperature goes down, it's because the particles move slower. If you want to see particles moving, I will not do it because we don't have lots of time today. If you go to PHET, it's a website that has lots of simulations. And I recommend you to try one that is states of matter, okay? After this stream, you can just go there, PHET, states of matter, and you will see what I'm talking about. You can see the particle moving and all that sort of thing, okay? So, whenever you see temperature changing, that is only referring to kinetic energy. Only referring to kinetic energy. And when the graph goes flat, you see that temperature is not changing. That is happening because what you are doing in there is not making the particles to move faster. What you're doing in there is breaking some of the bonding. Okay? What is the meaning of this? So if we want to pass from ice to water, liquid, we need to do two things. First, we need to make the particles to move faster. Faster. Because particles in liquid, they move faster than particles in solid. And once you get the particles to move faster, then we need to separate the particles a little bit. We need to break some of the bonding. And once you have achieved both of the things, then now you have water liquid. That is step number, you see, step number one is the ice warms up. And once we have the ice at the melting point, by the way, what is the melting point of ice? Anyone could tell? What is ice melting point? What is ice melting point? 0 degrees. Fantastic, credit scare. Fantastic, David. So once you get the ice warm up to 0 degrees, then what is happening is that we need to separate the particles a little bit. And once they are separated a little bit, now it turns into water liquid. Credit scale. Okay, thank you. And the same with water. Once you have water liquid, if you want to turn it into a gas, first we need the particles to warm up, to move faster, and then we need the particles to separate. Remember that kinetic energy and potential energy, both of them together makes internal energy, okay? Internal energy is equal to kinetic energy plus potential energy of the particles. I'm writing it in the chat so you do not forget, okay? Does it make sense? That is the reason of that shape of the graph, because there is one part of the experiment, or there is one part of the experience where we are changing is the temperature, and there is one part of the experience where we are not changing is the temperature, but we are changing is how separated the particles they are, okay? And the combination of both is what makes internal energy. All right, one thing I want to talk to you before we go is a specific latent heat and a specific heat capacity. By the way, a specific heat capacity is not in topic P6. I'm just saying you this for those who are like looking for in the book what is a specific capacity. A specific capacity is in topic 2, all right? But a specific latent heat is in topic 6. That's why some of you might be confused, Let me share with you. I would love to share the camera. Is this stupid camera is not working today because I like, you know, writing and going through the formula and everything. Let me find a specific heat capacity. Damn it. Specific heat. In the meantime, is there any part of the topic that... do we have to know pressure in gases? If you are doing separates, yes. If you're not doing separates, you don't have to, okay? Okay, meanwhile, I'm setting the PowerPoint. Let me talk briefly, very briefly, about pressure in gases. So, pressure comes because of the collisions between the particles and the container. So whenever you have a gas inside a container, okay? Yes, that's the general formula. Whenever you have a gas inside a container, the amount of collisions of the gas particles with the container, that is pressure. So now you need to think about what is going to increase pressure in the container. For example, temperature. Why is temperature increasing the pressure in the container? Because when you heat up the gas, the particles, they move faster, much faster, much faster. And that will increase the amount of collisions. That is the reason. I didn't want to, but since I see that this is going to be like a problem, let me see if I can set the simulation. And it will also be the chance to states of matter. And also, I recommend this website to every single one of you. I will put the website. Just give me a second. I will set the website and you will see the particles moving and all that sort of things and how we can change the pressure and all that sort of things, okay? All right, the website I'm talking about is... Okay, now it's not coming out. Yes, that's the website. Fantastic. Good. I want to share my screen. What top tips? I would recommend you to make sure that you know how to rearrange formulas. Okay? That's a massive problem nowadays. Good amount of sleep, oh, definitely. But that is always you need to sleep properly. All right. I wanted to share my screen, but today clearly is not the day for technology. To be honest, I wouldn't revise much in the morning. What you know, you know, and what you don't know, you don't know. If I were you, I would go to bed reasonably early and then just wake up like, let's say like 6. Yes, but you know I'm not allowed to enter in... I don't know why it's not showing my screen. What's going on? Okay, just give me a second. I'm not allowed to get into the... how do you say? Into the main hall. Into the exam hall. Because I'm a physics teacher, so they will not allow me to do it. Okay, no, this is not what I want. Oh my god, this is very frustrating, guys. But anyway, I think someone shared the link earlier. So just click in that link and... Aha, wait a second. Perhaps I will be able to do it. No. No. I can't. Anyway, that is the website. Just click in there and play a little bit with the simulation and you will see what I'm talking about, okay? Briefly, what does increase the pressure? Temperature increases the pressure of a gas. The amount of particles increases the pressure of a gas. obviously there are more particles, there will be more collisions, okay? Just common sense. And also if you decrease the volume, there will also be more collisions, okay? When I used to explain this, I always give the example of people dancing in a club. If you think about when you are in a club dancing, okay, you collide with people around you, all right? So what is gonna make the amount of collisions more frequent? Well, if there are more people, more collisions. If the temperature increases, people will get anxious and people will collide more. Makes lots of sense. And also, if the place, the area of dancing gets smaller, people will also collide more. So all those three things will increase the number of collisions, and whatever increases the number of collisions increases the pressure. Does it make sense? For the person who asked about gas pressure, does it make sense? There is also something that you need to know, which is called Boyle's law. Please revise Boyle's law. Boyle's law has the formula P1 times V1 is equal to P2 times V2. And basically, it helps us to find out how much will be the pressure or the volume if we change one of the factors, okay? But this is only for separate signs. If you're not doing separate signs, please don't ignore, but you don't need to know about Boyle's law, okay? What I wanted to talk about is a specific heat capacity, which is finally, because this computer is also in the last of its period, I can show you a specific heat capacity, okay? As soon as I save some money, I will get a different laptop, okay? Okay, this is the one, but let me see if I can show you as a presentation. No. Anyway, let's leave it in here. So, a specific heat capacity is the amount of energy we need to heat up an object, 1 kilogram object, to certain temperature. For example, if I have 1 kilogram of water, the specific heat capacity, hello Maya, Maya 15, the specific heat capacity will tell us how much energy we need to heat up water from 20 degrees to 50 degrees, okay? That is the specific heat capacity. And the formula we have for a specific heat capacity is the one you have in there. Let me explain what is each of the symbols. So, triangle E is change in energy and is measured in joules. M is mass, measured in kilograms. And it's gonna be recorded. You also have it in YouTube, okay? But yes, you can ask anything you want. C is a specific heat capacity and it is measuring joules per kilogram Celsius. Please make sure you get the units for a specific heat capacity because it's a very common mistake. It's joules per kilogram Celsius. So it's joules / kilogram Celsius. And then triangle with that 0, that is change in temperature. So again, a specific heat capacity is the amount of energy needed to raise up the temperature of 1 kilogram substance by 1 degree Celsius. No, capacity, no, Celsius. Celsius is joules per kilogram Celsius. Celsius. Okay? Remember that Celsius is temperature. Alright? So it's joules per kilogram Celsius. Alright, so a specific heat capacity is the energy we need to raise up the temperature, from one temperature to another one. However, something that is new is a specific latent heat. A specific latent heat is not the energy that we need to change the temperature, is the energy that we need to change the state of matter. To change the state of matter. And I want to show you where is, here it is. specific latent heat. Where is it? Where is it? No, this is not this one. Anyway, a specific latent heat is the energy that we need to change the state of a substance. No, the number of particles changes it because what you have is more particles, therefore there are more probabilities of collision. That's why the amount of particles changes the gas pressure, okay? That's the reason. It's because more particles, more probabilities of a collision. Does it make sense? It's not because of the movement, it's because of the amount of collisions, all right? There are more probabilities of collision. All right. And the last one, I don't know why my laptop is sabotaging me, is latent heat, which is not coming out. Ah, look! I managed to get the pressure. Oh, nice. All right. This is what, for those who are doing the PhD, this is what's supposed to be there. Okay? Yes, I think someone is sabotaging me. Okay, but it is a good opportunity because I will show you how the simulation works. I didn't expect this to happen. And look, it will help me to show you how the temperature and the pressure changes, okay? But this one doesn't have pressure. This one has pressure. This one has pressure now. Okay, I see that it's not very... You don't see very well. I made it too big, right? Today is not my day with technology. Okay, there you go. You see that it has temperature and pressure, yeah? Yeah, probably. She joined later, so she could hack me. Anyway, so look, in here, on the top, we have temperature, and here, pressure, okay? On the right-hand side, we have pressure. On the top, we have the temperature. So I just want you to observe what happened with the pressure. Look at the pressure, okay? It's the one on the top left for you. Look what happened with the pressure when we increase the temperature. You see what happened with the pressure? Why increasing the temperature increases the pressure? Because it increases the number of collisions. Anything that increases the number of collisions will increase the pressure. Okay? Yes, there is a positive correlation between pressure and temperature. Does it make sense? But this is not what I wanted to talk about. I wanted to talk a specific latent heat. Oh, finally. Okay, sorry, the program is also very slow. So, why is so big? Why nothing is working today? Maya, please, could you stop hacking me, yes? All right, there it is. Okay, so a specific latent heat. I mentioned just 1 minute ago that a specific heat capacity is the energy. Yes, I know, but I don't want to stop. If I change the resolution, I will need to stop, and you are here. So let's leave it for now. I know it's a bit like lots of pixels in there, and I know there was like a black empty gap in there. I close it. Let's focus in the learning. Another day I will focus in the screen and everything. Anyway, I just mentioned a specific heat capacity is the amount of energy needed to raise up the temperature. However, a specific latent heat is the energy that we need to change the state. That's all. The amount of energy that I need to change the state of a substance. The main difference between the formula for a specific heat capacity and for a specific latent heat is that a specific latent heat does not depend on the temperature. Why? Because when we are changing, when we are doing the change of a state, when we are changing is the bonds between the particles, but not the temperature. And this is something you can test. If you go to your kitchen and you get a pan, you fill it with 1 kilogram of water, and you start boiling. With a thermometer, you check the temperature. You will see that temperature increases, goes to 100, and in 100 it stays there for a few minutes. It doesn't change. It doesn't go to 101, it doesn't go to 102. It stays at 100 for a few minutes and then goes up. Why is that happening? Because when it reaches to 100 degrees, which is the boiling point, now the particles, they are not speeding up, the particles are getting separated. So whenever the particle heats up, that is a specific heat capacity. Whenever particles they separated, is a specific latent heat. They are different energies. It's not the same the energy that you will need to increase the movement of the particles than the energy that you need to separate them. Those are two different types of energy. The energy about movement is kinetic energy. The energy about separating them is potential energy. Since they are two different energies, that's why we have two formulas. One, to heat it up, is a specific heat capacity, and the second one, to separate the particles, is a specific latent heat. This is like I ask you guys, you are on your skate and you are moving and you're coming downhill. There are two energies involved in that process. There is one energy that is the movement, that is kinetic energy, but there is also you going downhill is gravitational potential energy, something you are revising right now. So in here is the same thing. We have two energies. One, we need to heat up the particles, make sure that they move faster. And the second one is to separate them. We need both to change the state of the substance. Okay? I know it's complicated. I'm aware of that. That's why this topic P6 is not the easiest one. Alright? What I'm going to do is make sure that you all have all my notes and everything in Teams. And to answer any question in here that you might have, I will stay here a few minutes more for answering your question, that they could be about this topic or they could be about any other topic, including if you have any exam question that you would like me to revise. I am more than happy to solve it in front of you and to go over it. Okay, so a few minutes. Is there anything you would like me to solve it now? Any exam question you'd like me to talk about? Any topic that I have been going through today that was not very clear? Now is the moment. Tomorrow is not math, tomorrow is physics. Graphs. What graphs do you mean? What graph do you mean? The all important graph tomorrow is the one that goes up, flat, up, flat. That is the graph that is going to be in the exam tomorrow. But apart from that one, I don't think there will not be more graphs. Okay. Let me have a look to people who are in YouTube if they are writing anything. Okay, we have 4 people in YouTube. I say hi to them too. We love them too. If there is any question, please make sure you write it in the comments and I will answer them later. Cubic graphs. Cubic graphs. That's not in physics tomorrow. That's not in physics tomorrow. And the national grid is in your exam? Yes, national grid is in your exam. Remember that national grid is the combination of all the cables and and the transformers in the country. So let me explain this in a language that we can all understand. Yes, that we can all understand each other. So the national grid includes the step up, step down transformer and all the cables from the power station to our homes. And the useful thing about the national grid is it doesn't matter how was the electricity produced. Doesn't matter if it is hydropower, nuclear power, fossil fuels. Doesn't matter where the electricity is coming from. all the power plants, they use the same wires and the same transformers. That's why it's useful for us, okay? What you also need to remember is what is the step up transformer doing and what is the step down transformer doing. The step up is increasing the voltage, decreasing the current. The step down transformer decreases the voltage, increases the current. So they are doing the opposite, okay? And the national grid is the combination of the wires and the transformer from the power plant to your home. Electric current. What is electric current? Electric current is the amount of electrical charges flowing inside a wire like this one, per second. And it is measured in amps. No, half-life and radiation is not in the exam. Okay? It only goes from the exam goes from P1 to P6. The step-up transformer, the step-up increases the voltage, decreases the current. Okay? I will write it down in case of you are just writing note. Increases voltage and decreases the current. Okay, there you go. In the chat is now. More questions. I'm enjoying this a lot. Come on, give me more. Give me more. Yes, Maya is hacking us again. Maya is hacking us again. More questions. Come on. Anything you like me to answer. Related with physics, obviously. By the way, I can confirm that there will be a special live stream on Sunday, and I will do it with another teacher of school. Plug is in the exam, yes. Remember that all our plugs in the UK, they have 3 wires: live wire, neutral wire, and earth wire. Remember that the live wire is red-brown and it has 230 volts. Neutral wire is blue color, 0 volts, and then we have the earth wire, which is yellow with green stripes, and it has 0 volts. Electric field, you need to know the definition of an electric field, and you need to know about what is static electricity. At what time? Probably in the morning, but stay tuned. Look at the stories in Instagram or in Twitch and you will know about that. It's not a science teacher. What else? What is a specific latent heat of fusion? So a specific latent heat of fusion is the amount of energy needed to change the state from solid to liquid. I repeat. Let's repeat again. Amount of energy needed to change the state of 1 kilogram substance from solid to liquid. I can write the definition. Amount of energy needed to change the state of 1 kilogram substance from solid to liquid at its melting point. There you go. I am your servant. Absolutely, you are the boss. I'm doing all this to help you. I'm doing all this to help you. The whole idea is that you don't need to, I mean, you can, but you don't need to spend a fortune in tuition. If I can help you, I'm here to help you too. You can spend a fortune in tuition if you want to, but my point is, not everyone has that opportunity. So if I could help you for free, let's do that. Okay, so yes, I can write the definition. I can send it to you. If you can, I can also share with you my glossary, whatever you need. Okay, come on, more questions. We have 1 minute more. Okay, so about fields. Okay, so any particle that has charge, which is basically protons that they have positive charge or electrons that they have negative charge, around them there is like a region around them, yes, that is like what we call the electrical field. To give you a metaphor, it's like someone who uses perfume, and around that person there is an area, okay, that everyone who gets inside that area can smell it. So the charged particles, it means like the proton or the electron, they have an area around them that if any other particle gets in that area, in that region, there will be an attraction or there will be a repulsion. Where are we going to see attraction? When we have a proton and we put an electron inside that electric field, there will be attraction. But when we put a proton next to a proton, the electric field is going to be an electric field of repulsion. When does static electricity happen? Static electricity happens when we rub each other two insulators, and what is going to happen is a transfer of electrons. And we're going to have electrons on the surface of the object, okay? And that object that has electrons on the surface, we will be able to attract objects. I can, you just need to remind me in Teams, but after this I'm gonna go and have dinner, okay? But if you remind me in Teams, I will do it later. The altitude affects gas pressure, yes. So there is something that is called atmospheric pressure, okay? So we don't feel it, but on us there is gas on us. Basically the air. But we don't feel it because since we were born, we have this gas on top of us. Okay, hello, AK-47 the King. So on top of us, and as we get higher up, what is happening is that we have less gas on top of us. That's why, hello Lebronzo, that's why when people go and climb Everest, yes, Mount Everest, it's much more difficult to breathe because there is not as much gas pressure, and it's much more difficult to breathe because there is less oxygen as well. All right? So yes, when you go up, gas pressure decreases. Gas pressure decreases. Okay. More questions, and we are going to leave it in here. Was there any question that I skipped? Hello everyone, hello. Very happy to see you, hello. We don't say names. Okay, I think there is no more question, okay? Okay, that's all from me then. So this is getting now recorded. You can see now in Twitch, or you can see in YouTube. You can go through the topics again, through some of the definitions. If still you have any question, you can write me wherever you can find me, and that's all. Thank you for being here. There were times that we managed to have up to 20 people in here, which makes me very, very proud. I'm very happy with the stream we had today. And we also went through some of the questions. I love having some interaction because otherwise it's just me speaking to the camera, and it's obviously much more fun if we are having a conversation. That's everything from me today. Good luck tomorrow. I'm sure you're gonna make me proud and make us, all of us, proud. The rest of you, keep tuned. Keep coming lessons. On Sunday there is one special one, which is probably not going to be like a lesson. It's going to be like a chat with another teacher. Another teacher will be here with me doing it. It's a special one because we reach more than 110 followers. And don't forget that even after the exams, we're gonna keep going with the lessons, okay? Thank you very much for being here, guys. Have a lovely evening. Ciao, ciao.